I didn't think I was tired, but I think it just hit. Yeah, frozen granola part. I'm Carrie Voyevich. I'm a research scientist at NASA Goddard and the project scientist for NASA SNOWX 2023. We're here in Alaska in Fairbanks measuring snow in the boreal forest.
On your breakfast.
We're in Creamersfield Farmers Loop research site right now. We have 3 sites here in Fairbanks, and then we have 2 sites on the North Slope in the tundra. The goal for SNOWX is to improve our remote sensing capabilities of snow, different properties of snow in different environments and at different times of the season. Water is so important to the western U.S. and they've had some snow droughts over the past decade, and so understanding how much water is stored in the snow is super important. Right now that means either airborne measurements or sending people out to make manual measurements, which doesn't cover the entire western U.S. So what we're hoping is that our measurements will help us understand what technology could be used on a satellite mission that could then collect measurements over that entire area. So kind of core measurements take place at the pit locations. We take very detailed profile measurements of the snow in those pits, including temperature and density, liquid water content. And then around those plots, we're taking very detailed depth profiles. And then further out from there, we're taking just a lot more depth measurements. All of that is within the flight lines of the radar and the LiDAR observations, so that we can connect what those observations see with what we measure on the ground.
We're headed to Bonanza Creek Experimental Forest, and we're going to do a bunch of pit measurements out there and depth measurements where we characterize snowpack in different locations, and that will be used for ground truth for the airborne flights and instruments that we have flying over the same area. About minus 20 Fahrenheit here right now, and I'm continuing to put on clothes because I just got out of the truck and that was pretty warm, and I'm changing body temperature very quickly. For a 2-up, which is 2 seats. And
I'm with the USDA Natural Resources Conservation Service. We actually are tasked with making water supply forecasts for the entire western United States. We have about 600 different watersheds that we model and deliver seasonal runoff forecasts for.
The reason why we look at snow density is so that if you have a given snowpack of 5 feet tall, the amount of water when you melt it all down could be close to 1 glass full of water, or it could be more like 3 gallons. We gotta do these measurements in the field because even though there's a lot of technology that allow us to look at it from a satellite or a global perspective, they have various ranges of accuracy, and so doing it in the field is one of the most accurate ways to do it.
at this site, we measure the snow water equivalence, and the snow water equivalence is the amount of snow you have in one spot if you melted it into water. So it's the snow water equivalent, and that's the fundamental holy grail parameter that we're after. If we knew how much water was spatially distributed over the entire planet, that would allow us to forecast spring runoff much better.
Water resources are just so critical, especially out west, and I think it's really cool to try to do the science to figure out how much water we have. Looking at the snow depth, so the height of the snow from the ground. I'm putting my ruler in the same spot we took the other measurement so that we can have 2 data sets. I also then look up and note if we have a canopy kind of covering the surface or intercepting the surface, because that's an important note for our pilots who are looking over and trying to measure the snow as well with the airborne LiDAR.
So as part of SNOW-X, we are conducting these airborne experiments, collecting active and passive microwave radar data. And we are only one part of the whole effort. You see the lines on the down below, lots of lines. I think that's essentially the handiwork of the ground crew, trying to validate measurements. First crossing.
Whiskey Fairbanks approach radar contact, center left downwind, runway 2 right.
My name is Batu. I'm from NASA Goddard Space Flight Center, and I am the PI for the SWISAR instrument. It's called Snow Water Equivalent Synthetic Aperture Radar Radiometer. It's very similar to how a bat transmits sound waves as it's flying around, and then listens to the echoes, trying to make sense of the world, the three-dimensional world around it. We do the same thing with just the microwave, so our waves travel at the speed of light, they come back to the antenna, we collect them, and we process those echoes to make sense of the 3D world. It is in conjunction with the ground measurements that the field teams are doing. They're digging snow pits and collecting other snow observations for these to validate what this radar and radiometer is seeing.
We are walking to our snow pits and the tower radar instruments. It's super cold. The surface temperature was minus 34, 35 Celsius this morning. So coldest day of the campaign so far.
Yeah, so this is a radar sensor. And so we'll compare this with the ongoing flights of this campaign. This sensor is particularly suitable for deep snow, whereas some of the other techniques are likely much more suitable for shallow snow. So this is very complementary. So this will take half an hour to finish. So we do 4 of those transects, so this takes 2 hours.
So they want to test instruments in all these different snow environments to make sure that they work globally. Alaska offers a perfect snow to do this type of test. We have a boreal forest, and Arctic tundra is very different. It's generally shallow, but it's much harder. A lot of wind-blown features, and the variability is amazing. So these are very different types of snow, and it's important to see that the instruments for remote sensing measurement of snow, they do work well in these different snow environments.
It is a massive effort in terms of like community participation. We would never have all these measurements on the ground if our crews were smaller. So the fact that we can get so many people in one place to take measurements is really meaningful.
The team has become really close. It takes a lot of camaraderie and a lot of people pitching in. You cannot stand on your heels and watch what's going on out here. Everybody has to pitch in, and it makes for a really tight group.
Working out in these conditions is just physically demanding. It's super cold. Here in the boreal forest, the snow was very light and fluffy, and we were tromping around in the woods on snowshoes. I mean, really in the woods, off trail, and it was just very physically demanding. I am amazed at how much data was collected. You are an incredible group of people. This was super, just a super opportunity and a really great experience to be part of. So I appreciate all of the hard work, and it was not easy. I heard somebody say like, "Wow, you guys work really hard for this data," and I thought, "Yeah, this is a lot of work." So thank you very much.